question 68 is an application. It's fairly similar to 67, which is in the assigned homework. And so I thought we'd work through this one together, and that leaves you 67 to try on your own. 68 deals with a college theater, okay? And the college is going to set aside, X will be the number of tickets that they're setting aside for students. Y is the number of tickets that they're setting aside to sell for general admission. And then we're told 4 things about those numbers, and we're asked to translate each of those into an inequality and then graph the solution set. All right, first of all, the total number of seats available is 2,000. Well, that means the number of tickets, the total number of tickets that I sell can't be more than the number of seats. So the total number of tickets that I sell would be X plus Y. That would have to be less than or equal to 2,000. It's okay if I sell fewer tickets than I have seats. It's okay if I fill every seat. It's not okay if I sell more tickets than I have seats. All right. The next piece of information, the college reserves at least 3 times as many student tickets as general admission tickets. Okay. Another way of phrasing that is that X, which is the number of student tickets, has to be at least 3 times the number of general admission tickets. It has to be at least that. It has to be greater than or equal to 3 times Y. Now, these last 2 things are sort of common sense. We can't have a negative number of student tickets. That would mean X has to be bigger than or equal to 0. And we can't have a negative number of general admission tickets, and that would mean Y has to be bigger than or equal to 0. As is the case with an awful lot of applications, that basically says we're going to be just working in quadrant 1 and on the boundary of quadrant 1. We're working with variables that represent non-negative quantities. That's not true of every application, but it's often true. And you might say that was silly of the book to include that. On the other hand, it's kind of them, I think, to include that, because when we go to graph, we're so used to just drawing our X and Y axis, and really everything that's going to be taking place has to be taking place here in quadrant 1, or possibly on the axes that are boundaries of quadrant 1. Okay, so if we're not careful and we just say, oh, let's graph this and this, if we're not careful, we accidentally include some parts with negative numbers. Okay, so I'm actually just going to go ahead and say that these 2 inequalities put us in quadrant 1 or on the boundary. Okay, now we've got, for this one, I'm going to go ahead and get Y by itself. So I'm going to subtract over the X. So Y would be less than or equal to negative X plus 2,000. So let's see. I'm going to just let this be 1,000, 2,000. So my y-intercept here is at 0, 2,000. My slope is negative 1. Now I'm letting tick marks here represent thousands. So I don't really have, it's kind of hard to see what going down 1 and over 1 is. But as long as my tick marks represent the same amount, going down 1,000 over 1,000 also gives me a slope of negative 1. And this is going to be a solid line. And notice that's going to cross the x-axis here at 2,000, because if x is 2,000, the opposite of x would be negative 2,000 plus 2,000 would give me y as 0. Okay, we wanted to shade below that. So that's going to look something like that. Okay, then we've got a red marker, which I had to find. This was our next inequality. Again, I'm going to just get y by itself. So I'm dividing through by 3. So we've got x over 3 greater than or equal to y. Kind of prefer to have y by itself on the left. So I'm just going to rewrite that as y less than or equal to x over 3. Notice, if I think of that as an arrow, it's pointing to the y. Okay. So my boundary curve is just y equals x over 3, or 1/3 x, and that's also going to be a solid line. Okay. Now, that's just a line through the origin. The y-intercept is 0, 0, 0, rather, and we're going up 1 over 3. Again, my tick marks happen to represent units of 1,000, but as long as they represent the same amount, up 1,000 over 3,000 does the same thing as up 1 over 3. It's the same slope. And I'm connecting that with a solid line, like so. And let's see, we wanted y to be less than or equal to that, so we're shading below that. So that's going to look something like so. Okay. And so now I can draw my final graph, which would just look something like so. We've got this sort of triangular region that's below both lines. Because both lines were solid lines, this point where they meet is actually going to be a point that we have right here. So that's what our solution set would look like.